So today I'm here to talk about this specific graduate degree program at UTSA, which is titled Master of Science Degree in Advanced Materials Engineering. And like I introduced earlier, my name is Ethan An, and I'm a faculty member of Electrical and Computer Engineering at UTSA, and also I'm a graduate faculty member of this specific program, Advanced Materials Engineering. Right, next. Okay, so here is the agenda for today's presentation. So I'll be spending about 40 minutes to talk about those aspects here. So I'm gonna a little bit talk about myself and what I do here at UTSA to give you some brief introduction about your speaker today. And then because this program is specifically dealing with a subject called Advanced Materials Engineering, so I thought maybe I can give you some brief idea of what this subject area is basically. So the materials as an interdisciplinary area of study. So I'm gonna talk about that a little bit more. And then after that, I'm gonna give you some specifics about this program, like in terms of history, features, and who are the faculty members and who are the students and all that. And then at the end, I'm gonna give you a little bit of interesting videos that are available in YouTube to basically highlight some of the very interesting research activities that our faculty members in this program are currently doing, and one of them will be mine for sure. And then at the end, you'll learn how to basically apply it to this program. Okay, next. Okay, so speaker introduction. Next. So here's some little bit more piece of my information here. So in case you have any questions or you need to talk to me by any chance after hearing this video. Then feel free to let me know. So I'm actually working on many different areas in nanoelectronics, and my specialty is basically on using nanomaterials for example future computing hardware. And currently we have these conventional computers and even supercomputers, but researchers are actually looking into many different ways for, say, next generation computing hardware. So say 10 years later or 20 years later. And that includes actually neuromorphic computing that is trying to basically here, neuromorphic. So that is trying to mimic how human brain does. And then, they try to bring these interesting features of human brain into real computer. That's called neuromorphic computing. And also the nationwide and also globally, there are a lot of, research initiatives in quantum. So I'm also working on various kinds of materials to basically implement this quantum computing. And I'm also working on some other interdisciplinary areas. So I'm gonna keep saying interdisciplinary anyway, today's talk. But I'm also working on biosensors, energy technologies, and hardware security and all that. And when it comes to my educational background, I got my PhD from Stanford University here. And this is a group photo, and you can hopefully find me here. Next, before actually joining the UTSA faculty here, actually I got lucky to work for Apple in California. And then, if you had any iPad, specifically like a 5th generation 9.7-inch one, by any chance, then actually there should be some touch sensor in there that is detecting your finger motions and all that. So that touch sensor actually was developed by myself. So that's probably some interesting story about myself. Next. And then, when it comes to research, this is basically some quick portfolio of these numbers in publications and also the grant awards from many different sponsors that includes some US federal agencies such as National Science Foundation, Air Force, Department of Transportation, and all that. Next. Yeah, so, and then this is actually a picture of very beautiful building where my lab is located. And, UTSA has this thriving downtown campus right now. And, my lab, I think my research group is, probably the only one research group in College of Engineering who has research laboratory in downtown campus. And we are actually doing a lot of research in here in this building, and you see this UTSA Nanoelectronics lab sign here. Next, and I think the next slide is so giving you some little bit of snapshot of the research lab inside with a couple of my students. Some of them graduated already, and some of them are still working in my lab. And this is some picture in the research lab. We had some UTSA nano electronics lab mixer. So all the students and faculty and relevant personnel, they all come together to talk about some technical stuff, and also enjoy some food and drinks and all that. And because of this COVID-19 thing, usually I do have these meetings right now with Zoom online. So this is also some pictures of this Zoom meeting, and it looks like they look very serious. Of course, because we are talking about research thing, so sometimes it goes very serious and kind of challenging sometimes. And so right now I have currently 10 students in my supervision right now, including 6 PhD students here and 3 master students here, and also a couple of other undergrads, some visitors, student interns, and some other faculty on sabbatical leave, and all that. Next. Yeah, so there's some brief introduction about myself. So next I'm gonna move on to materials. Okay, so next. Okay, so if you haven't heard about this program by any chance before, then this is really interesting program actually that UTSA has here, and that's called Advanced Materials Engineering. And this specific area of study is actually very, very fundamental, I'd like to say, because materials is basically the most fundamental and primitive building block for any engineering systems that you're going to build. No engineering systems can be made without materials, right? And then it is at the interplay between fundamental sciences and engineering principles. And this is also because materials is the most fundamental study area. And like the presentation title, it had this interdisciplinary specifically. So, it's very special in terms of, it is very close to many other different, areas and disciplines here in engineering. So even in pure sciences. So it is very close to what electrical and computer engineering does, and even mechanical, biomedical, chemical. And even it is related to some fundamental sciences, including physics, chemistry, and biology. I'm sure you'll be learning a little bit more later on. Next. And in order to give you some, some better idea of what we are actually doing here. So let me take this laptop computer as a really interesting example here. And here the goal is to give you some better idea of what this materials engineering program does, okay? So what is this? So basically, next, yeah. So this is a laptop computer, right? For sure. And this is a specific type of, I'd say, computing system, because we may have different computers, right? For example, desktop computers, and even your phone is also a computing system. And we may have some data centers in Facebook, Amazon, and all that. So we have server computers, and we have different computing systems. But this is one specific example of computing system that you may have. And here, when you say system, and then you like to say, okay, I want to work on, I like to study system, then it actually means you are actually working on a unified whole that has a specific purpose. So which is computing in this example. Next. So I'm gonna keep zooming in, okay? So see, what is actually inside, okay? So if you zoom in this computer, then obviously, what you're gonna see first is going to be some sort of architecture, all right? So my pen is not working for some reason. Okay, so you'll see this architecture. So architecture, basically, by definition, it means planning, designing, and constructing a certain structure. So here in computer architecture, you're gonna have many different components, like input devices, output devices, some memory, CPU, GPU, and all that. But here the point is, how you actually structure them. Okay, so how do you put them all together nicely so that they can actually function as a whole system, okay? So if you are really studying on, for example, architecture, then basically what you're gonna do is to look at this structure and then design and implement what would be the best structure for your function, okay? Next, and let's go deeper. So, if you even zoom in into this architecture, then electronically, actually what you're gonna see is this electrical circuits. Okay, so you have, for example, this motherboard, okay, motherboard, and if you have any chance to open up your computer by any chance to fix it, or to do some interesting things inside. But I'm sure you have seen this circuit board anyway. Okay, so then this electrical circuit has this interconnection of all these electrical components, and this is going to be also another separate area of study that focuses on a little bit smaller scale than architecture, but basically dealing with the same fundamental connections and structures and all that. Okay, let's zoom in. Let's keep zooming. So next. So if you zoom in more, then your circuit is something that you can see easily. But starting from now, you may not actually see easily by your eyes, because right now the technology actually advances very quickly and in an amazing speed. So what's inside is actually something called what researchers call devices. Okay, so these devices actually mean, for example, transistors, resistors, inductors, capacitors, all that, and that is the smallest unit of those components. Okay, that has its own functions, I would say. And believe it or not, if you zoom in, like this microprocessor chip there, okay, that is as small as, for example, your palm or fingers, then you know what, actually you have billions of transistors, not hundreds, thousands, okay, billions of transistors in this small microchip. Okay, and those individual devices, even if you zoom in, then this is some picture of microscope, electron microscope image. Then you see, even it's very hard to see here, but you can see that there are many different small scale things that again we call devices. Okay, next. And even you can zoom further, okay, further into these devices, then you're gonna finally meet materials. Okay, so these devices, for example, if you zoom in here, then I'm not gonna explain to you all this like technical details too much. I don't want to scare you, okay? But we have this technology called the FinFET right now, and this is one of the modern transistor structures that we have. I believe all the electronic devices right now, you have phone, laptop, computer, and everything. They are all based upon, built up based on this technology here. And again, if you find individual elements, yes, then we have some sort of material, okay? And I believe everyone knows now we live in the era of silicon, right? And although, there are many researchers who are looking into, because we don't know until when, we are gonna use silicon, right? So maybe for many years later, there might be some other new materials coming in, and then there'll be the winner. But we still use silicon, and also there are a couple of other materials here. I don't know if you can see here clearly, but we have some copper, which is some interconnecting wires, and you have some dielectric materials, which is insulators. So it's all combination of different materials, okay, inside your device. So the materials can include semiconductors, conductors, insulators, metals, and oxides, and all that. Okay, so that's why, if you like, then we can even further zoom in. Then there are also many other interesting things inside. But basically, in terms of all these study areas that we do in engineering, it's basically based on these materials, the very bottom level of your study. Okay. Next. So if I summarize all this, then I just drew this hierarchy of electrical and computer engineering studying here, but not necessarily electrical and computer engineering, but any general or other specific disciplines in engineering. I believe this is how they are located here. And again, the systems, again, it means a computer. Then you have. And under this, you have architectures, the circuit board and motherboard and input and output and all that. And under this, you have circuits, you have CPU, memory, and all that. And then at the very bottom, you have devices and materials. Okay, so they are, for example, silicon and transistor. So, but the bottom line is, again, I like to highlight that materials is the most fundamental area of study, which actually forms the basis for all these other engineering products that you have, okay, in the real world. Next. Okay, so that's pretty much about introduction. So until now, I really hope everyone in this session, you were able to grasp some big picture about this materials program, right? And then I'm gonna talk about a little bit more specifically about this advanced materials engineering program at UTSA. So next. Right. So this is basically a graduate degree program, right? So we offer Master of Science in Advanced Materials Engineering, and it's kind of relatively new program. I mean, it is founded in 2012, like about 10 years ago. And I'm going to talk about this interdisciplinary feature later on in a minute, but this is a interdisciplinary graduate program offered by the College of Engineering for sure. But when it comes to all the paperwork and the administrative things, actually the Department of Electrical and Computer Engineering has it. So it's kind of under the umbrella of College of Engineering and Department of Electrical and Computer Engineering. And the interesting thing about this program is you can think this program is very focused and relatively small size program that has almost like 1-to-1 student to faculty ratio. That's going to give the students really wonderful time and plenty of time actually to talk to faculty and interact with other students in the group, in the program, so that would be really nice feature of this program. Next. Okay, so these are a little bit more technical things here. So if you like to hear about, okay, so this guy is saying they are working on materials and because it has advanced, so it certainly means that we are not researching the current materials, but our focus is more on the next generation or advanced level materials for the future. Okay, so what you're gonna get by participating into this program is going to be basically fundamental knowledge and also some engineering skill sets, okay, in material science engineering in general. So specifically, these are some examples, but not, I mean, limited to this, but the examples of the subjects that, we are currently doing here actually include, some structure property relationships in materials, which actually determine the behavior at a lot of different scales, micro scale, macro scale, and even nanoscale, molecular scale, and atomic scale. So here, the important thing is by learning about how this material is made, I mean, how this material is structured, actually that's going to determine the material's physical properties. So there should be a very close relationship between them, and that's going to be one of the most fundamental knowledge that you're going to learn from this course, I mean, from this program, I believe. And when it comes to some specific tasks that you're going to do as a researcher, that actually includes, you're going to have some chance to synthesize the materials and make your own materials by using, a lot of equipment and facilities, instruments, for sure. And you're going to also some characterization study and measurement study for this kind of ceramic materials, composite materials, and many other materials. And you know what? Interestingly, there are some materials called meta materials. So I think this is good to be highlighted here because we are working on advanced materials. And this meta material, I think one of the keywords that people really like to say about right now is something called metaverse, right? So the Facebook and many other IT companies, they are really like to work on this metaverse technology, and then they believe this is going to be, the next generation enabler or something. So that's kind of similar here. So because it has meta, okay, in front of material, so that actually means any material that can be engineered to have a property that is actually not found in naturally occurring materials. So it's like more like a very engineering-driven, kind of. If you want, then you can say, it's kind of artificially made, materials kind of thing. So, the engineers can bring all these novel ideas to even create materials that have never been existed, okay, in history. So, of course, our end goal, our ultimate goal, is not only just to study these materials and publish papers and all that. In addition to that, we actually want to use those materials actually to address some of the current or future technological challenges. Okay, so that's what I believe engineers actually need to do at the end. And of course, in order to do this, you need to learn about how we do design and apply those materials to address some specific societal challenges that we have, for energy, sustainability, health, even healthcare. They are all related to this advanced materials engineering program. Okay, next. All right. So yeah, so this is a really good piece of information, for our faculty members here. And I'm here, and I'm not listed as the first because I'm the most important or something. I think that's just because my last name starts with A, so that's it. But this program actually has a lot of faculty members here who are actually led by our program director, Dr. Ryuan Guo here. So she is leading as a program director for this. And also we have a lot of other faculty members for sure. And notice that what are their educational backgrounds. I mean, and also which specific area they are working on. So for example, we have EC faculty members, physics faculty members, and even we have some industrial partner here. So they are working in SWERI, which is the Southwest Research Institute that we have in town here in San Antonio, and applied physics, biology, BME, biomedical engineering, and information and systems, and even cybersecurity. So you see, they are very interdisciplinary, and we all together, we form this group of faculty members who have very diverse educational backgrounds and research expertise. So that's why we call actually this program very interdisciplinary, and we want to educate students also in this sense, because I think the engineering problems right now are getting very, very complex. So compared to the many years before, it's very hard to solve the engineering problem by one single discipline right now. So that's why we all gather together, and also even students. I'm going to talk about students a little bit more next slide. But that's why this program is built. Yeah. So this is a kind of interesting snapshot of our recent student alumni, so who graduated from this program and earned this master degree program. I mean, earned the Master of Science degree in advanced materials engineering. And like you see here, just like the faculty members, okay, they all have different backgrounds and expertise. So look, this is the I think these are highlighting their educational background in their bachelors. Okay, so which background they actually already had when they joined this program. See here, materials, even biomedical physics, petroleum, computer engineering, chemistry, biology. So they span across all different programs in there. So I believe it's not not only helping this program, but also students actually can learn even with this different diverse background, even it can make their even career better, again, because engineering problems right now, in order to solve them, we need a lot of different people, network, and those interdisciplinary technologies here. Next. Yeah. So, and also maybe you are also interested in knowing like where they go, okay, after graduation. So I mean, here are, not all of them for sure, but this is I think good examples of where this master program in advanced materials engineering program alumni work right now. Okay, so that actually includes some very major kind of industry company, semiconductor industry company, like Intel in Oregon, Hillsboro, and advanced materials, and we have advanced materials in Austin, Texas, and some other many other companies that goes across many different sectors and areas in our society. So I'm sure they have been very successful in terms of finding a job, and also they really like the job. And I hear from the students that, one of the reasons that they got so successful in job search was because of this program. I mean, they really were able to, for example, use the knowledge that they learned from the courses that they took for example, their job interview, or the skill sets they learned from this program. They were exactly what these hiring managers were looking for. So I believe this program has been very successful in terms of student job search and all that. Next. All right, so for the remaining time, I think, so hopefully, I mean, by now, you guys so excited about, okay, so you understand materials is a very fundamental program and interdisciplinary program, and they have like this, one-to-one student to faculty ratio. That sounds perfect and good. And, I just highlighted, some historical things and features and all that. So here, what's coming up next is basically rather than I just kind of give you a lecture, okay? But I just want you to experience some of the really exciting research activities that were already highlighted in media. So for example, we have these 3 faculty members, actually 4 faculty members. Dr. Gu, again, who is the program director in this program, and that's me, and Dr. Teja Guda, who is, I think, the faculty member in biomedical engineering, but also part of this advanced materials engineering program. So let's see what kind of researches they are doing by looking at this video. So the first one here comes up, Dr. Gu and Baller. They are actually the group of researchers who was able to create the smallest medical robot in the world. And I think this has come up in a Guinness record. So for how small they can be. And I think it'll be interesting to look at this video here. So I think that's going to be about 2 minutes. So yeah, let's look at the video right now.
On the night made a major feat accomplished with a very tiny robot, actually the world's smallest medical robot.
Even with Guinness World Records says so. The award was presented to UTSA after a team of researchers developed the invention. The night team Sarah Acosta introduces us to that team and shows us how the robot works.
It's not what you may expect a robot to look like. This is a nanorobot. It's more round in shape and has a magnetic core. The shell around it acting like its arms and legs. It was created by Satik Patel with some help from advisors Amar Bala and Ruan Go.
Sometimes very difficult to explain to people.
Professor Go says a magnetic field and electricity help make the robot move. Check it out in action as it moves through a series of cells. It's so small you can't see it with the naked eye.
Just to give you another idea of this, how small it is.
Professor Amar Bala says the robot is so small you would need to divide a human hair 1,000 times to get it down to the same size as the nanorobot. The size is impressive, and so is its ability to move to specific cells. The research could lead to a more targeted form of treatment, especially when it comes to chemotherapy and cancer cells.
You really want to suppress their growth, but hopefully not impact other healthy cells. Currently, we don't have a technology that could do that effectively.
In this video, you can actually see the nanorobot line the cells up. Guo hopes this could also help researchers figure out a way to reconnect broken neuron passages in Alzheimer's patients. There's also research into printing nanoelectronics onto special material for the skin that could track your temperature.
Reporting your body function, whether you are deprived of sugar or too high in sugar level.
So many possibilities for the future, and the research is far from over. Sarah Costa, KSAT 12 News.
So hope you got excited, right? And the next one comes up here is my own research here. And you know what? One of the research projects that I'm working on here is to actually develop electronic devices that have this, say, immortal batteries. So that the batteries that never die. And I think that sounds really crazy, something that can come up in sci-fi movie or something. But I'm taking these novel materials, advanced materials engineering techniques, to actually see. Actually, whenever I, for example, travel, one of the most biggest headaches that I have every time that I travel is to bring all the charging cables, for example, for my phone, laptop computer, tablet PCs. I don't know how many cables that I need to bring for every time. And I'm very tired of collecting all these cables. And anyway, so if this research actually goes well, then we can see some bright future that actually has very high energy efficient electronics, and they may even not need any battery at all. So let's look at this video real quick here. That's going to be another 2 minutes.
It's nice to imagine a world where your cell phone's batteries would almost never need recharging. But that could be a reality if Ethan Ahn's experiments at the University of Texas at San Antonio, or UTSA, are successful.
We want to develop devices that can operate almost without batteries.
That potential is based on two tiny things, a thin layer of carbon, just one atom thick, called graphene, and electrons, charged particles that already power most of our stuff through electricity. Because electrons are constantly spinning, they also carry another form of energy. These scientists are trying to harness what they call spintronics.
Electron is a little but very powerful magnet. So imagine an electron which spins in its own axis, either up or down.
So far, researchers have only been able to harness about 2% of an electron's spin energy. So the UTSA team is using this sputtering machine to create a lattice of graphene to hold and move those electrons and gather a lot more of that energy.
Using graphene is a new approach to spintronics. Not only it is one of the strongest nanomaterial out there, but there are ways in which we can change its or modulate its electron conductivity.
If it works, the applications are huge, from batteries that almost never need recharging to quantum computing that uses the up or down spin of electrons the same way bits of information are used as the foundation of all programming.
So if we are successful, then we can increase the energy efficiency a lot, which is going to be a very important step for quantum computing.
The researchers are being supported by the U.S. Air Force Office of Scientific Research, which needs batteries that can operate in the field without recharging. Kevin Enix, VOA News.
The third piece of research is done by Dr. Guda here in College of Engineering, UTSA. And I think he is doing a lot of interesting research using this what's called a 3D Bioplotter. And you'll see what kind of medical devices and also many other useful devices actually by this technique. So let's see this video also.
The mission of the Regenerative Medicine and Device Innovation Lab is to develop the right tools that allow biomedical science to actually reach clinics and serve people. And we're using the Bioplotter to literally do this generation's version of rocket science.
We use the Developer Series 3D Bioplotter. We're trying to come up with the next generation of implants which we can actually use our scaffolds and grow weight-living tooth that eventually would be placed into a human instead of a traditional implant.
So we're creating tissue-engineered scaffolds to help people with damaged bone, muscle, tendons and ligaments, and dental tissues, and promote a more native wound healing process. There's a really large veteran population here, and a primary reason for why we got into this space is to give back to the young men and women who serve the country who can get their own native tissue and quality of life back.
The versatility of the machine is what has allowed us to keep advancing our field. We have found out that our bioinks are mostly printable at really low pressures and low temperatures, which is something really hard to do with a typical 3D printer.
So the ability to actually be able to not just develop the materials, which is what traditional material scientists are working on, pair it with the cells, which is what traditional biologists work on, but be able to pair them together with the right technology that could one day take them to clinics. I believe we are very much the cutting edge of science, or the biting edge at least.
Please feel free to consider this program to apply. And lastly, I'm gonna talk briefly about, how you can actually join this program. So next. Yeah, so basically all the information is available online. And, when it comes to this specific materials engineering program, you can find out, in our web page. And also we have this program brochure online available. And when it comes to the procedures and what are the requirements and paperwork and all that for, graduate school admission process, you can always visit UTSA Graduate School admissions website here. Next. I think one of the most updated information for potential students right now is that, although we have, don't be scared. I mean, this is like a very standard, norm of application document for any degree program in engineering, I believe. But, when it comes to some test scores, usually, for international, for both domestic and international students, we usually have, GRE and TOEFL exams actually to be taken and submitted. But for now, because of this pandemic situation, the GRE is not actually required anymore. And also for international students, TOEFL requirement is also lifted, kind of temporarily for now. So I think you can grasp this opportunity basically to kind of make your whole application process easy. And make your life easy and all that. So this is for your information about application documents. And next, and here is some important deadlines. So for fall, spring, summer, you can join at any time. One of these semesters, and there are deadlines for differently for domestic and international applicants for sure. So make sure you are aware of these deadlines and feel free to apply. Next. And when you decide to apply, actually there are 2 degree options that probably you can know about this program. And we have 2 different tracks here. So one is the thesis track, and the other is non-thesis or project track. So for this first one, thesis track, we actually require the students actually. Let me see here. So for this thesis track, you have to earn total 30 credit hours during your tenure until graduation. And one of the requirements for this thesis track is because it's called thesis program because you have to actually complete a oral defense presentation at the end of your graduate program. And there is another option for students, which is non-thesis track. So you are not required to make any oral presentation, but you have to take some more courses in our program here, and then you can do your research individually with your research advisor actually. So there are 2 options, degree options here. Next. So I think that's pretty much it for today, and thank you for your attention. And again, here is my information, name and email address. So feel free to email me if you have any questions after this session. Thank you. I'll be happy to get any questions if you have.
Do you have any networking tips for international students who might find networking intimidating or difficult?
For international students, it's really true that building up a great network with researchers and faculty members and other colleagues in the field is very important. And if you like to hear from me, if there's any useful tips for that, I believe the best one is directly contact your program advisor or the faculty members here. And I think one of the very nice features that we have here at UTSA is that, as far as I know, most faculty members, even here in this specific program or in general at UTSA, they are very willing to support students, and they are very kind enough to provide very tailored advices for students. So my first advice, the best bet for you for now is to feel like a very free, not scary or not hard, difficult to contact these faculty members here. So I think because specific advices should be really depend on your background and your career goals, and basically all these details. So I cannot really say in simple word here, just do this, but I think if you contact me or any other faculty members that you find interesting to work with, then feel free to send an email or contact them. I think you're gonna get a lot of useful tips from there.
Are faculty receptive to prospective students reaching out to them directly?
Sure, absolutely, yes.
What are some important factors that you think students should consider when they're choosing between graduate programs?
I think specifically for this advanced materials engineering program, the most important thing is to have passion and motivation actually to learn about some basic fundamentals. So like I said in my presentation, this program, the research that we are doing here in this program is kind of unique in the sense that we are dealing with both fundamental science and engineering applications. So if you believe you are the person who, of course you are the future engineers, but you also care about why this system works this way, or why these devices work this way, or what are the fundamental technologies behind. If you have curiosity for this kind of subject, then I believe this program is the perfect fit for you. And if you like to get better prepared for this program, then I encourage you to read some the research papers or articles and magazines, and who are actually trying to talk about those emerging materials technology. And then if you get excited, or if you get any questions on that, then you can always reach out to us. But basically that's the basic idea that I wish the future students to have. And I think in general, for any engineering programs, if you like to get yourself prepared better, then I think number one is this curiosity, because no curiosity means no research. And number two, you have this strong motivation actually to be a leading engineer in this area. So that's the mindset that I want future students to have.
For students who are considering doing a PhD after their master's, would you recommend that they choose the thesis track versus the non-thesis track?
For those who like to do PhD after this program, I definitely encourage you to choose a thesis track. Yeah. So because this thesis track is more, I believe that's more towards the specific research, as well as how to present and how to basically disseminate your research results to outside. And when you come to the PhD program, then of course you're gonna learn a lot more about the specifics and engineering skills and all that. But I think the fundamental difference between master's program and PhD program is you have to really produce your research outputs. So in terms of patents, publications, presentations, and thesis and dissertations and all that. So I believe it'll be a really good practice and experiences. If you can complete a thesis track, if you are interested in doing a PhD here.
What made you interested in nanomaterials? What helped you decide what to research?
That's exactly why we are all here. Why we, the faculty members and staffs and all the people here. So, my recommendation is, no worries for the first time. Okay, so if you don't have any very specific, clear idea on what material you like to research, because again, that's going to be given, or that's going to be greatly helped by again, your advisor and colleagues after you join the program. So, but if you can have a little bit of rough idea of for example, electronic materials, magnetic materials, dielectric materials, thermal materials. So if you like to have any like a bigger level of idea of what, not very specific, but in general, what a broad sense of material category you like to research, I think the best is again to do some search on the papers, research papers. And I believe, there is a specific research paper called review paper. Okay, so I hope you know the difference between, in general, research paper and review paper. So research paper is a study that really specifically focus on one specific topic. okay? But review paper is quite different in the sense that it's more like for beginners and, you know, for those who start with, and, you know, it doesn't specify any specific study of, for example, materials, but they kind of give you some broad overview of what's going on, and, you know, researchers are interested in this in general, and this is the background, and, you know, those informations are all there in, again, this paper called review paper. So if you are interested, if you like to do, then feel free to, you know, search on, you know, those review papers that were written by renowned research members, faculties out there. So you can maybe put some keywords like a review paper. If you're interested in nanomaterials, okay, so review paper, nanomaterials, review paper, biomedical materials, review paper on blah, blah, blah. So you can do some search to get some idea to start with. But again, the specific research project and what to choose, and, you know, those will be discussed and pretty much determined very well in discussion with your advisor after you join the program.